Greetings, Saintsmen. We're going to start with lesson 1.2, which is the lesson on points, lines, and planes. I'm sorry, on measuring and constructing segments. Uh, I'm just looking at this stuff for 1.1, losing my mind, fellas. End of the day. So today we're going to encounter a few things as we do this. We're gonna talk about something that's going to be synthetic versus what's real, and I want us to understand this, and it's this in the same vein that we discussed these ideas of a point, and then we're gonna get into it right away with constructing a line. So let me get some more tools here. I gotta have more geometry tools in this. Let's see, writing tools. Where are you? That's not it. So I can get effectively what I need right here as I write. Um, as we discussed previously, when I have these arrows at the end of a line, and I have going to define a couple of points, A and B is what I'm going to name this to get the minimum of information that I need uh, to construct this line. And for example, we have this right here, and it's this end arrow, and this means that this is going to extend infinitely, right? So, um, again, ways that we're representing something theoretical and for it to be physically manifested, where we can have this idea that exists in the mind versus something in actuality that we can represent here and discuss. Because again, geometry, the root words, metric like to measure, but geo means the world. So it's us trying to look at how to measure the the world that we have around us. And well, we have a point, and that's where we're going to define and confine ourselves within space, and go from one thing to another and say that we physically have some sort of space or distance that we can define in between the two objects. And we give a finite boundary between each of those things. So it's something that's largely it's real to us, but it's highly theoretical simultaneously. So your textbook, for example, is going to get into something that is called the ruler postulate that I kind of snicker at and I'm a little bit dismissive of, but we're going to utilize it from the standpoint that something a uh, has a measurement, okay? And whatever that is, we can define that. And effectively, you guys see just in raw mathematics, just a number line. But that number line, pragmatically, is something like a ruler. So we can have like for the 1 inch mark to the 8 inch mark, it's just like a number line, right? And then we can find that distance in between. So right now we're going to do a construction that we're going to do in class together. And we'll work on this guy and do it again on I'll do it in class for you briefly, and then we'll work on it again next week. In a week, next Wednesday, Tuesday and Wednesday. And this construction is the copy of segment construction. It works as follows. So I'm going to take my compass, and I have this area that's right here, this distance between A and B. And what I'm going to do here is I'm going to take the width of that compass, and I'm going to put the needle of it, right, the little metal part. I'm going to put it right here on A, and then I'm going to extend the little pencil to be here on B. And then I'm going to put now the needle onto this point, which is going to be C. And then without adjusting it, I'm going to make this other little mark right here with my compass, which is going to give me my point D. All right. And again, it's very difficult for you guys to see it just like this. I'm going to have to show it to you guys in class. Okay. Now, what this does is this has made a segment here. Both of these terminate, right? Or in other words, it ends. So it terminates here and it terminates here. So while this line extends infinitely, there is a confined amount of space in between these 2 points A and B, which we can define as this line segment. All right. Now, what we get is whenever we have some measure, and we could take whatever unit we want. We could just say this is 1, and then we can name the unit that is the length between A and B. But if we're consistent with those units, we now have a means for taking measurement. And when we have something that has the same measure, it is what we call congruent. Now, we will talk about congruence, and it's going to also apply to angles, which we haven't really discussed yet. You guys have some prior knowledge about angles, but we haven't done that yet in this class, and we're going to have to define that in this entire logical system and structure that we are creating together as we explore Euclidean geometry. So, moving on, I have here AB, in this case, which is equal to CD, okay? And of course, this means equals. But now I have a new form of notation when I have had two things that have the same measurement, right? Not that I can quantify them the same way, but now if I can measure them the same way, I'm not just saying theoretically I have 6 of this and have 6 of that. What I have in this case is I have 6 inches, right? And then 6 inches, when I have the same amount of something measured, it's what's called congruent. And this little symbol right here, the equal sign with the squiggle on top, this means congruent. Okay? So, let's actually see if we have something that's going to be congruent. Here, on a number line. Okay? And I have here A, B, C, and D. Okay? The question being, is AB, are AB and CD congruent? Okay? Now, for on this number line, again, these are going to have tick marks for the number line. Okay? And then, so I don't have a point that's defined here. Oops. Let's go back and make sure I have my line there. Just get rid of the point. Tick mark. Okay. But I have these points A, B, C, and D defined on that number line. And then now we're going to actually take, and your textbook uses an absolute value, but you guys can just use a counting principle here. AB here is going to be equal to 2. It's 2 spaces, right? And then CD here is just going to be equal to 1. And what you're going to see is that AB is not congruent, right? They do not have the same measurement, because the measurement of AB, right, as we measure these tick marks, would be 2, and then CD is measured out at 1. So then we can take to show it's not congruent is we have the congruent symbol, and we literally just put a, oops, we don't erase it, my bad. We literally just put a slash through it, okay? Means not congruent. All right. Now, the ruler postulate is not something we're going to, utilize really ever in the course. The big one, though, that is a reason as to why something exists, it doesn't require proof, is we're going to work with really our first important and lasting postulate here, and significant, as I should say, which is the segment addition postulate. Now, notice, this is how it's formulated, is that it's saying that if B, which is going to be a point, is between, because it's a capital letter, right? So if B is between A and C, then AB plus BC is equal to AC. All right, so this is how we construct that. Let's actually give this guy a picture. I have my line, and I have some points. So I have A and I have C, which B is in between them. All right. And then what the segment addition postulate says is that AB, that segment, plus BC, right? This plus this is going to be equal to this entire thing, okay? AC. This is what I call, and it's very important, I require this. This is the key to success on your next assignment. okay, is that you must provide me for every segment addition problem a segment addition statement. You have to do it, okay? Have to give me a segment addition statement. We are going to do some arithmetic that I'm very confident in your ability to complete it. All right? Otherwise, you wouldn't be in a high school geometry course. Like the next problem, which is our example, where I have on this line X, Y, and Z all on a line. And XY is 14 and XZ is 27. All right. And I want us to find XZ. Now, the purpose of this, gentlemen, is to make sure that we are doing this and we have fidelity with what our actual concept is, that we're following the rules and have a good and have fidelity to structure. In other words, I don't want us just saying, looking at this and be like, oh yeah, XZ is just going to be, and you can just spit out the answer to me because you can add 14 and 27. Gentlemen, congratulations. You can add these two numbers. Some of you guys can do it mentally right now very quickly. That's not the purpose of this exercise. It's, again, to practice the form and structure. So, again, don't worry about what it looks like. Worry about what the problem actually says. We're going to have to provide a segment addition statement, which is that this segment, xy, which shares this coordinate y, plus yz is going to give me xz, which is the whole purpose of this thing. I'm trying to find xz. All right? It's right here. Here's xz. I'm kidding. XY, now we can substitute, okay? 14 plus 27. And I think some of you guys have the habit of putting things in parentheses when you substitute in. And then 14 plus 27. And you're allowed to use a calculator. Why not? Okay. Is going to be equal to 41. Haha, 41. All right. Next. I have B, C, and D. Okay. BC is 19. And this entire segment right here is equal to 25. And we are going to find CD. Now, note that there is no segment subtraction. That's not a thing, okay? The only postulate that we have, the only thing that we don't have to, and I don't understand you guys, it's the, well, it's obvious, right? Well, I get that. I get that you guys can back that out. I get that you can formulate this algebraically and then do the mental math. But the idea here is that that's not the purpose of this exercise. The purpose of this is to utilize the rule that we have in place. And the key is that the reason that these segments can add up on the line is because they share this coordinate, right? Or they share this point, right? It's like not even a stopping point. We can actually put these two things together, right? So, by the way, as I work on this, I do actually see the chat right now. If you guys do have any questions, you can feel free to leave them in the stream chat as I work here on Twitch. Getting back to the problem, let's create our segment addition statement, okay? And this is required for every single problem. You're going to do this a few times in class, okay? So we have BC plus CD is equal to BD, right? Segment plus segment is equal to the segment. BC is 19 plus CD, which is what we're solving for, is equal to 25 when we substitute. All right. And then we do this algebraically. We're going to subtract 19 from both sides. Okay. And I'm left with CD after I cancel the 19s out. 25 minus 19, which is equal to 6. And that is my solution. One last problem for you guys today. Here we go. And make some segments here. These ones will be P, Q, and R. All right. This guy is, PQ is 8y plus 25. PR is 13y plus 25. Okay. And we're going to find QR. PQ plus QR is equal to PR. Okay? That's my segment addition statement. Segment plus segment is equal to the whole segment. PQ plus QR, which just shares the point Q, is equal to the entire thing. And now we just substitute, right? I have 8y plus 25. Okay? And that is plus QR. Okay? And that's going to be equal to 13y plus 25. Ooh, yikes. Why do I have plus 25? Guys, I'm sorry. Hey, real quick, I just made a mistake. Sorry. Mistake. I just made... This guy should not be 25. This should just be 5. My apologies. I just made a huge... It's called a transposition error. You guys do this all the time. I do it all the time, too. Is that you see something, you just write it the wrong way when you copy a problem down. It doesn't mean that you have any sort of procedural error in terms of knowing how to complete the structure of a problem or knowing the algorithm, right? The problem solving methodology. The issue is just I just wrote the wrong thing. Okay. So here we go. Now I've got the right thing. So it should have a 5 right here. Okay. Not a 25. Just paying attention to this 25 and I just got in a rhythm. Okay. So 8y plus 5. I'm going to subtract the 8y's from both sides. Cancels and cancels. So 5 plus QR is equal to 5y plus 25. All right. And then I'm going to get in here and I'm going to subtract 5 from both sides. And my QR is plainly going to be 5y plus 20. Now, gentlemen, I don't have a solution for y. If I did, I could input it here to get a different numerical value, but this is all I can do, and this is what I'm left with in this problem. We may encounter this tomorrow, so be careful. I just want you to solve literally for what I'm asking you to do, okay? You may not get a numerical answer, but you may. That's all I got for you today. Gentlemen, I will see you in class. Good luck.